All right, in this video lecture, I'm going to go through 5.3, the final section in chapter 5, and it's about electron configuration and periodic properties. Basically, I'm going to talk about periodic trends that we see, and those trends deal with atomic radii, ionic radii, ionization energy, electron affinity, and electronegativity. And so we will look at the trends as we move across the period or the row and down a group or a column. And so that's what this section is all about. So first up is the atomic radii. So atomic radii is related to electron configurations. With the definition of the atomic radius, it's basically 1/2 the distance between the nuclei of identical atoms that are bonded together. So here's that, here's that, here's that, and ionic bonds. It doesn't really matter, but just know that the atomic radius is half the distance between the nuclei of anything that's bonded together. So the trend for atomic radius is as you move across the period, they gradually decrease. And that is because the atomic radius is related to electron configurations, the electrons and the outermost energy shell. Well, as you move across the row, we are adding protons to the nucleus, and protons have a positive charge. And so what it does is it increases the positive charge on the nucleus and pulls on those electrons even more. And then when you move down a group, it will increase in radii because you're adding energy shells. Okay, here we just have one shell. Now we have 2 energy shells, 3 energy shells, 4 energy shells, and so on and so forth. So the trend is the atom size decreases as you move across and increases as you go down. So a sample question regarded to this. Scroll down and read it. Of the elements magnesium, chlorine, sodium, and phosphorus, which has the largest atomic radius? Okay, so we go back. I have magnesium, chlorine, sodium. Okay, here's sodium. Here's phosphorus. Here's chlorine. I forgot the last one. Magnesium. Okay, so we would definitely say sodium, okay? Because it's the furthest down, okay, the groups, and the most left element where it's the greatest, because if you move across, it decreases. Which is the smallest? So the smallest would probably be chlorine, okay, because it's the furthest on the period, like across the row, okay? So we'll say for right, smallest is chlorine, so largest on the electrons. Okay, great, we answered it. Moving on to a second trend, ionization energy. So removing electrons from atoms to form ions requires energy. So electrons can be removed if there's enough energy supplied. Here's my atom plus energy, and we strip that electron, and now it has a positive charge because there's more protons than electrons, and here's that electron. Now if I slap that electron back on the A, then it becomes neutral. So an ion is an atom, not at, or a group of bonded atoms that has a positive or negative charge. Ionization, any process that results in the formation of an ion. So chemists compare ionization energies, which is the energy required to remove one electron from a neutral atom of an element. So here they have it spaced out, and you notice that our highest belong to which group? Okay, it is the noble gases, and our lowest are elements found in group 1, which is our alkali metals. So it doesn't take a lot of energy to strip that lone electron in group 1, but it does take a lot of energy to strip electrons because all of their energy levels are filled. So across a period, main group elements increase, and then again, it has everything to do with proton charge along the same sublevel. It attracts the electrons more strongly, so you need more energy to strip them away. And then for main group elements, it decreases as you move down a group, and that is because we have a larger electron cloud, and they are further away than the outermost electrons in the nucleus. So we tend to find our highest values over here. Okay, helium's got the highest, followed by neon and argon, but there's ionization energy. So when you remove electrons, you form positive ions, and this little bit you don't really need to know, but energies of for the removal of additional electrons are referred to as second ionization energy, and if you wanted to remove a third, then it's third ionization energy. And so the second is always highest than the first, and the third is always higher than the second, and so on and so forth. And that is why it takes so much energy for elements that have a full outer energy shell to like lose electrons. Okay, they'd rather gain them. Okay, so it says, what trend do you notice in regards to locations in the periodic table? Is that as you move across the period, it increases. Oh, I think I was supposed to have a shield. But anyways, whatever. Consider two main group elements A and B. Element A has a first ionization energy of 520. Element B has a first ionization energy of 1687. Decide if each element is more likely to be in the S block or the P block. Okay, which element is more likely to form a positive ion? So, what I'm trying to get at is element A, because it has a lower ionization energy, it's probably going to be in the S block, okay, because the S block only loses 1 to 2 electrons, where element B has a higher energy level, so it's going to be in the P block, okay, so electrons are more difficult to lose. A is more likely to form a positive ion, and that is because of the lower ionization energy, and also if you think about S block elements, whenever lithium loses an electron, it becomes positive. Sodium, also positive. Okay, so you can also add electrons to form ions. Okay, so we call this electron affinity. So ionization is when you take electrons away. Electron affinity is when you add electrons. So here's my atom, it's neutral. I add an electron, and now it's kind of negative. So across a period, it increases. And again, we're adding nuclear charge. We're adding protons to the nucleus along the same level, so it attracts electrons more strongly. And then down a group, it generally decreases because for the same reasons. The larger the electron cloud, the further away its outer electrons are from the nucleus. So they are not held as tightly. So here is electron affinity, basically the same trend as ionization energy. So when atoms become ions, the radii do change because it's based on where those electrons, the outermost electrons, are. So cations, because we're losing electrons, we see a decrease in atomic radius, and the remaining electrons are going to be closer to the nucleus or pulled closer to the nucleus. Anion, because we're gaining electrons, will always lead to an increase in atomic radius, and the electron cloud is spreading out. So the ionic radii trend is as we move across a period, it decreases because the electron cloud decreases due to increase in protons in the same energy level. But when we go down a group, now we're adding energy levels, so it increases. So there's my atomic radii. Okay, I highlighted it to show that as you move across, it decreases, and then as you go down, it increases. So far we've talked about ionization energy, electron affinity, atomic radii, ionic radii, and so we still have to talk about electronegativity, which we'll get there. So a little bit about valence electrons, even though you know what they are already, but compounds form when electrons are lost, gained, or shared between atoms, and so it has everything to do with electrons being lost or gained or shared when we make bonds. When we make those bonds, we make compounds. Or molecules. So they're usually located in incompletely filled main energy levels. Like sodium here has 1 valence electron, that's why it's in group 1. Chlorine is a halogen. It's found in group 17 because it just needs 1 more electron. It's 1 away to pretend to act like a noble gas. So it's usually the outermost energy shell. So they have abilities to capture electrons, and that ability is called electronegativity. So the measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. So when we move across the period, they increase. And when we go down a group, it decreases or stays the same. So our highest element the element that has the highest electronegativity is fluorine, and that value is around 4. So red means high electron affinities, which means that is not what I wanted to say. Red is highest electronegativities, which means they have a higher ability to attract electrons from other atoms in a compound. Green, not so much. So sample problem of the elements gallium, bromine, and calcium which has the highest electronegativity. So gallium, Ga, crap, I already forgot the other ones, short brain, calcium and bromine. So gallium, calcium, and bromine. Okay, so we're definitely going to say bromine, right? Which is the highest. So they're all located in the fourth period. Bromine is the highest because it's furthest to the right. Therefore, bromine should have the highest electronegativity. Easy peasy. Now, properties of the D block metals do not vary much. We notice that in the D block transition metals, the atomic radii decreases across. For ionization energy, they increase across and increase as you go down. For ion formation, and ionic radii usually form cations with various charges. And with the electronegativity, we see an increase as radii decrease in values between 1 and 1.1 to 2.5. Okay. And that does it for 5-3 notes.